Hi everyone, I'm really grateful to be here today in Droidco, Berlin remotely. Thank you very much for attending me here. And today I would like to present you my talk about Kotlin Multiplatform and Kotlin Multiplatform multithreading and what was an old multithreading approach and new multithreading approach. My name is Anna Zharkova. I'm lead mobile developer in Tech Software Company. And so I'm sorry. And here is few words about myself. Currently, I am also not only a native Android developer, I'm also iOS developer, and I'm really fond of cross-platform mobile development. Xamarin and Kotlin Multiplatform. I'm Kotlin JVM in Kotlin Multiplatform, and also I'm a mentor. I'm a leader of mobile team. I'm a speaker in few conferences. I'm an author of some articles. So as many speakers in DroidCon. So that's nothing special. And also I'm a woman technique ambassador. So now let's take a look what we will discuss today because time is running. Today I would like to discuss the first about Kotlin multiplatform and its common concurrency approach. During this talk, we will take a look at how to work with coroutines in common code for Kotlin multiplatform, how to solve problems in Kotlin Native, and what are the problems in Kotlin Native. Also, we will take a look at such instruments and tools as background workers, advanced sharing, flows in Kotlin Native, how to work with Kotlin in iOS side, and of course, we will talk about how to deal with all the things in new memory model and what have already changed before this new memory model becomes stable version. So at first, let's talk about Kotlin Multiplatform. It is a special cross-platform SDK from JetBrains company. This special tool will allow you to simplify your cross-platform mobile development because you can share of all of your common code in special model, and then this model will be compiled by virtual machine, special virtual machine for every target you have specified in the project in special kind of library. For example, if we are talking about mobile development, of course, I will mostly talk about mobile development because I am mobile developer, not a backend developer. So in this context, this special model will be compiled in special framework for iOS and special jar library for Android. The same code, and it will be compatible with both platforms. So you can share in this model everything except of your UI, because Kotlin multiplatform, it's not about UI thing. And also two specific things as work with devices, sensors should be also placed in your native projects, not in this common model, but all of them data for business logic and for common architecture layer could be placed here. One of the specifics of Kotlin multiplatform is that this common model uses in different part of this different version of Kotlin language. For example, for common main part of your common model, common shared code, there will be Kotlin common code. And for Android and Java, there will be Kotlin JVM. And for iOS, there will be Kotlin Native. Also, it will be the same for desktops and macOS, Linux, etc. For web, it will be Kotlin JS. So it was a small introduction. What is Kotlin multiplatform is, if you are not common with this tool. When we work with the Kotlin multiplatform in really complicated projects where we would like to use really complicated cases, there will be the case of concurrency. We use expect actual modifiers to specify with expect what we would like to make common, and actual to specify what we would like to make differently in all our targets. Concurrency is one of such cases because concurrency in Android, in JVM, it's not the same that we will use in iOS side, because Android and iOS SDK are different. So there will be different cases of concurrency, and we need to specify them differently. When we work with all these targets separately, there will be coroutines for Android and special cases as Grand Central Dispatch for iOS. But how it will be implemented in common code? Of course, if our common code is Kotlin, there should be a Kotlin. Since Kotlin Native 1.4, all the suspended blocks in coroutines will be turned into normal function with completion handler with two parameters in response, the data and the error. So the same as result with the same content and error. So this is how suspend Kotlin transforms into Swift function. When we work with our platforms separately, we could specify different concurrency in every platform. But when we would like to have a most experience of shared code, we need to specify common business logic. And in this case, there had to be common concurrency. So there should be common coroutines for both our targets. And there could be several problems. Let's take a look. So when we specify the work with our concurrency, we need to provide two dispatchers context for our coroutines, for main thread and UI and for background working. So inside of Android, there will be no problem because all the dispatchers are default, and dispatcher default is used for Android default, and dispatcher's main is unique for every platform. If we will take a look at what is under the hood of this mechanism, we will see that main dispatcher is selected with several parameters, and these parameters depends of your platform. So if your platform is supported, there will be the instance of main dispatcher for your platform. So let's take a look what we will do with Kotlin Native and iOS, because it's everything okay with Android and Java, because everything works with Java Virtual Machine. So in this case, let's take, for example, and use default dispatchers as we do previously for Android for iOS. So this will not work in your project because there is something wrong. What is wrong? In many cases, for example, when you work with such ready-made solution as Ktor, or you have implemented something by yourself using iOS code from Kotlin side, there will be freezing exception. And in most cases, it's really strange and it's really hard to understand what's going on. So something goes wrong, let's fix it. To work correctly, we need to specify our own dispatcher. Let's specify our own dispatcher as an implementation of coroutine dispatcher class and overriding dispatch function. In this function, we will run our block of code and use some magic instance of freeze. So as you see in the slide, we use two dispatchers in this case. And it looks really strange because many of you understand that we work with the main dispatcher that works with the main queue for UI, but it will not be correct to work for background threading. So this was the problem with old approach in Kotlin Native and memory model. And it's already fixed in new memory model, and later we will see how this will be working today. But previously, that was only one solution. And we couldn't provide any dispatcher and coroutine dispatcher working with get global queue for iOS because there were no thread was bound for this background queue, and that was a problem. When we worked with the ready-made solution as KTOR, there could be no problem because KTOR already implemented all asynchronous work under its hood. And later we will see what are the mechanisms that we could use by ourselves without any third-party libraries to provide the same behavior. In previous slide, there were the magic code freeze. There is a sample rule how to work with threads in Kotlin Native. When we work with some mutable content, this mutable content could be used only in one thread. If we would like to share it between several threads, this content should be immutable. So in Kotlin JVM, everything is okay, so we are talking about only Kotlin Native. But this is the rule for every language. So to make object immutable in Kotlin Native, we should use special freeze code word, and our object become frozen and immutable. Easy. Let's take a look. How could we provide our correct behavior to work with our content, not only in main thread, but also in background thread? In some cases, you can find several samples in network, and they're also not only the sample how to work with own dispatcher with global queue, but also make our own completion handler and put here a frozen block of code. At first sight, it could be a solution, but we remember that this queue is not bound to any thread, and this is really doubtful. So let's provide another solution that will be working. If we have previously worked with coroutines, we remember that there is special global scope, and this scope at first sight allows us to work with background, but it is not recommended even by JetBrains company, even by their own specialists, because it causes potential leaks and losing of your callbacks. Of course, you could join all your jobs and then provide clearly the context, and it could also fix several potential leaks, but it's not recommended. It's not too convenient solution. So, and also we could face several freezing exception, even we have provided our freezing block. And what should we do in these cases? And what are these cases? When we work without singletons, everything will be okay with freezing blocks. But when we need to provide several singletons or constants, there will be such case of exception. In such cases, we need to provide special annotation thread local, and this special annotation is only compatible with backend fields, objects, or other singletons, not with the simple fields, properties, or etc. And this special annotation will fix everything. So everywhere where you use singletons, you need to provide thread local. So in this block, you have faced nothing new about how to work with threads in Kotlin Multiplatform and Kotlin Native and to solve concurrency problems with iOS. Let's take a look in several mechanisms that are implemented under the hood of Kotlin Native, and we should make some deep dive in it and use it in our code. So we remember that everything works differently in concurrency mechanism, even synchronization mechanism. So these mechanisms could also help us to make several part of work to provide better experience of our multithreading. and sharing of our context. For example, there is a sample how we could use it with Android and iOS. In iOS, we use special monitors or maybe some kind of other mutex. In Android side, we prefer to use Kotlin synchronized. Let's make our own concurrency using native and deep tools of Kotlin Native. All these tools are available in Kotlin Native and provided in its documentation. As a sample, we will provide our own network solution. So there will be our own network client to provide us the mechanism of ready-made concurrency without CTOR and coroutines. Okay, coroutines are optional and there will be several solutions with coroutines, but we will make all multithreading by ourselves. So the core of our HTTP client. We will speak about working in iOS side, not about Android, because in Android side everything is okay and we could provide the sample. Okay, HTTP, it's not interesting, it's not the topic for DroidCon. Maybe some deep dive in OK HTTP is topic for DroidCon, but it's not my today topic. So there is a sample of the client, how it works in Kotlin using the constructions from iOS Swift. So the same mechanism, URL session, URL request, and special task we provide with this request. What are the specifics of this code? As you can see, there are also several sharing mechanisms. It's my own extensions to provide freezing of this mechanism, because all these parts will be sharing between several contexts, so they should be immutable. This code need to be put on background threading because we need to prevent frozen of our application. So to prevent the frozening, we need to make it frozen and to make it shared with background threading. And receiving of our data will be put in main thread. As you can see, these blocks are in different methods because we need to specify the callback not in completion handler closure, but it will come in special methods of our listener. So we need to provide interface to put here the result of work of our client. The specifics of iOS URL session work. So how to work with background with Kotlin Native mechanism. In Kotlin Native, there is a special tool called Worker. And this worker allows us to make several work to create several features. And in this feature, we will execute thread safe the block of our code. And of course, we need to freeze our block at first and then run it. And also we need to collect all these features to clear all the reference in it to prevent memory leaks. So there is how we could provide the routing into background threading from the point. So, and when we have applied our block of code and put everything that should run on background in it, how we will return all this data and context, how we will switch to the context of main thread. At first sight, we could provide the callback in future consume closure for this case. And in this block of code, we need to provide the callback. But it still be the same thread at moment. How we will switch to main thread? To make it, we could remember that previously we have used dispatch get main queue to dispatch everything in main thread. That was the sample from our main dispatcher. In this case, we need to repeat the same code, but at first we need to freeze our block of code and then throw it in our block. So in future consume, we will put everything in main thread. So, and it will be working. But to prevent invalid mutability exception, we need not only to share everything. When we receive the callback and receive the data, there could be several cases when we will receive not all the data in one attempt, but there will be several portions of our data and we need to collect them together. So we need to deal with mutables. And how we should do this? To deal with mutables, we need to specify the special byte array and collect here all the data. But when we will do nothing with this, we could not make several sharing and freezing. And at first sight, we haven't frozen anything, but when we have used it in frozen context, everything in frozen context is already frozen. What could be done in this case? Thread local is not our solution because it's not backend field, it's not property, it's not so it's property, but it's not singleton. So how we need to solve this moment? Let's take a look. It's not our case. It's freezing exceptions and invalid mutability of frozen. Let's make it frozen at unfrozen at one moment. To deal with this, we need to use special solution of atomic reference wrapper. In this atomic reference, we need to put at first our frozen variable, and then we could refrozen it, unfrozen it, I'm sorry, change something and again frozen. And it will be working and without any crashes. But this solution leads to potential leaks. And we need to make this reference optional and then clear it. So let's take a look how we will deal with atomic. So there is sample extension that allows us to make our variable or property atomic. And then in special method, we need to specify the new value. It will be a new empty byte array in our case. Here at first, we will put everything from our previous atomic reference, the value, add new portion of data, and then we need to specify a new value of our atomic reference, and of course, freeze it. And do not forget to clear it with empty array to prevent the memory leaks. So, and it will help us to prevent memory leaks and crashes while working with immutable context and in cases when we need to make it mutable. Also, we can use the mechanism of detached object graph. So this is old mechanism, and in new version of memory model, it will be deprecated and there will be no need to use it. So, but in old version, this mechanism allows to do switching between contexts with several data. For example, in this graph, we could put as input parameter the triple with the parameters, the closure, the block of code, and the deferred future where will be stored the result of our work. Then, as a mutable, this detached graph need to be attached and as a pointer. And with this special pointer, we could get the access to all the values we have shared previously. So we have prepared the graph before switching to the context. In the context, we need to attach the graph and get a point, and then we could get the result and put the result at the completion block and return the deferred future where will be the result. So looks complicated and easy, the same at moment. But the graph allows to attach only once, so you have to create new graph with all the data every time you need to share it between contexts. So that was the old mechanism, and today there is no need in such mechanism, but for that was the mechanism in old Kotlin Native. So we could combine everything we have watched before with coroutines for better result and to make our work more convenient. For example, we could use channels, flow, and completable differs. Of course, channels are not too convenient and not too modern. It's deprecated, but we could use it with the flows and completable deferred. And in these cases, we could specify everything in special suspended block, a special suspended function. And in this suspended function, we could put everything, for example, in channel, all the data. This is instead of using byte array. And then we could consume all the data, put it in special value, and then return our response. So this is how it could be done with the channels. And of course, we need to provide special completable deferred as a sign and special signal to understand when we need to return all the data. So until this moment, until everything will be collected, we'll be waiting. So there is one possible solution. So the same could be done with mutable state flows in Kotlin side, and so there is not too much differences between how it could be done with the channels. At first, it will be completable deferred to make awaitable signal. And then we could provide everything in our own engine, and we could specify our own reader, the way and the approach we prefer, and then we could call the task, then await for response and provide this response to our user. So also completable deferred help us to solve lambda sharing. There is a problem of lambda sharing in Kotlin Native. And for example, for URL, it's really a problem because in iOS side, we have to use lambda as a native way to get the result of the URL session work. But in this case, we have previously used special kind of delegate and interfaces. So completable deferred will solve us this problem. It's not about how it could be done only with concurrency, but it's something for you know. So, and there is ready-made solution where everything is provided. There is my small library, how to work with all native mechanism in Kotlin Native. And it is not all my talk. And now let's take a look how we could do the same in new memory management model. So last August, JetBrains company announced experimental new memory model management, and we wait that in this autumn there will be stable release of this with better Kotlin Multiplatform. So for us, it will be the great release, and all the developers of Kotlin Multiplatform waited for this. So what's new in this new memory model? The main focus is in support safe sharing and change of thread context. So there is no need to use freezing. And this makes your code really clear. You could use atomic reference and freezable atomic reference without any potential leaks. No need to share immutable when use globals, and worker execute doesn't return isolated graph dependencies. And also there are several special things in last version of Kotlin. So the garbage collector is not single threaded anymore. So it makes our work really safe in our application will be performed and optimized better. And what's new, the newest moment is that the freezing is deprecated since Kotlin version 1.7.20. Also, what's new? Atomic references need risk in version 1.6 Kotlin, and there was the freezable atomic reference as a solution to use them instead of atomic references. And also there was several not too good news, I think so. For example, globals was lazy, but in many cases we need to provide them immediately, so we have to use special eager initialization, and there was also several specific of this mechanism. What was not good and really disappointed for many developers, there were no guarantee that suspended will return to main, and we have to provide several wrapping to route all this output to main thread. Also, the initialization of our objects could be called in other threads, so it could be also a disappointed moment. But there are also several advantages from version 1.7.20. So since this version, freezing is deprecated, and we could provide atomic references again instead of freezable atomic references. So we removed atomic references and then we returned atomic references, but without any frozen. We need to provide lazy instead of atomic lazy, for example, and we need to use type directly without detached graph. So there is several changes in mechanism of interrupt of C. And also there is a lot of description of how the freezing API is deprecated onto what you need to remove from your code if you haven't removed it previously. So let's migrate. The new memory module is available from Kotlin since version 1.6.0. But to make it turned on, you need to provide Kotlin Native binary memory module experimental in new Gradle properties. And of course, if you are an iOS developer, you need to use Xcode newer than version 12.5. You could face several problems with Xcode version 14, but with 13, it will be okay. So at first, let's remove all freeze blocks from our code. Even if this block is called freezed, it's not frozen. So it's safe to work with an unfrozen block and share them through the context. Everything done under the hood of Kotlin Native. So we are speaking about what is under the hood, but it is under the hood of under the hood. And also remove from other points of our code. So there is no need to use share, no need to use frozen, even from flows, channels, and etc. So there is an old point of code where is still be share extension, but there is no need to use freeze anymore in any context. And we return to atomic reference, but previously, when we used them in old approach, we have to frozen everything before pushing it as a value to atomic reference. Now we need to use atomic reference without any freezing. And we have to remove freezable atomic reference. That was a solution from version 1.6. So also we need to remove from other points where we use our values for atomic. So when we will use them with new values, there is no need to use freeze. And one of the most excitements, I think so, and really good advantages of this thing. We could use default dispatchers with iOS. With Kotlin Native, there is no need to use our own dispatcher anymore. we could specify default dispatchers for dispatchers default, dispatchers IO, dispatchers main, and then this coroutine will provide us the output that we are using our global queue dispatcher for Darwin. That means that all the background queues are bound to real background threads, and that's really cool. Also, there could be several potential leaks. So you have to put auto release puts over all your code where you will code all this specific code using your memory model. So in this piece of code on slide, there is no auto release put, but for better experience, there should be auto release put. And also, we could specify coroutine with mechanisms that was previously available only for JVM and Android. For example, we could use new single thread context to provide the block where we could put all our code that need to be specified in background. And it will provide us special dispatcher for every context, and there will be a special worker dispatcher working with background. So that could be a really alternative way for using background workers directly. And what else? When we use several libraries, there could be several implementation of freezing. Of course, all the libraries that are specific for Kotlin Multiplatform, all these libraries are updating every time. And in these cases, people provide us modern solutions supporting modern features. But for example, if we specify the version that will use freezing under its hood, we need to disable freezing in our code at the moment. And it could be done with several options, directly with Gradle properties or in our build Gradle KTS as a special binary option. But Kotlin Native, it's about iOS. Of course, it's DroidCon, and we are speaking about Kotlin and Android, but it is how to work with Kotlin with iOS. And to provide the better experience for iOS and make our work really multi-platform, we need to specify several solutions. When we work with our data in side of Android, we could use as live data as a mechanism to provide updated data for our view or state flow. Asynchronous flows could be a really nice solution to work with common code. So we could not use live data because it's Android specific, and we need to specify in our common code only what could be shared between our platforms. So the flows is our solution, and flows is an answer. When we call for the flow from iOS side, we receive such kind of output with several placeholders. So these placeholders told us that we need to specify a special collector that will implement Kotlin coroutines core flow collector. So in the world of Kotlin Multiplatform, all the paths to Kotlin specific code, all the packages are transformed in such kind of class name. Because of differences between of approaches, how are dealing with names in iOS side and Kotlin side. And also we need to specify specific completion handler. So to provide the collector, we need to implement this class and implement the function emit. And in this function, we need to collect all our data. We remember that all our data could be separated in different block of code. It could be a sequence of portions of data, so we'll need to provide them as a sequence. So, and when all the data are received, we are calling this special kind of completion handler. This completion handler could specify just tabs with the empty Kotlin unit and nil as a second parameter, as an error. And it could be also the solution. Another way is to provide a special kind of wrapper to our flow, and this flow could be used directly from the side of iOS, and we could receive the answer as a value in our completion handler, as we used previously when working with suspended function of Kotlin. And when we will connect everything, for example, in this piece of code, there is how we could provide our collector. We could call it observer, another name. So how we could receive all of this data and provide it to our model or our other part of business logic we prefer to use in iOS side. So let's summarize what we talked previously. Concurrency in Kotlin Native could be really hard, but with new memory management module, there will be no problems at all. It will solve all our pains and problems. We could provide everything equally in Android, for Android side and iOS side. For other targets we specified, and there is no need to provide several workarounds. And of course, there is a toolkit, and this toolkit mostly is not deprecated. You could still use it for your purposes or to know better what is working under the hood of Kotlin Native and Multiplatform. And there were several leaks in garbage collection, but there was several works to stabilize this situation, and that's really cool that we received the concurrent garbage collector, not single-threaded garbage collector, and the garbage collection at all in Kotlin Native side is become more convenient and automated in new version of Kotlin, and that's really cool. So there is several sources. Thank you for your listening, and I'm ready for your questions. I hope it was interesting for you, and there will be several questions. Or if there is now several questions, there is their sources, the managers, the messengers. Where could you find me?